The purpose of this video is to really compare and contrast the way that a traditional algorithm is taught and the way that a student that has gone through different stages to get to the algorithm thinks through the process. The first problem, I'm going to start with 412 divided by 4. And so the student would set it up, and I'm going to talk through it as if it was a traditional algorithm, and we would say 4 divided by 4 is 1. 1 times 4 is 4. We would subtract and bring down the 1. 1 divided by 4 is 0. 0 times 4 is 0. Subtract and bring down that 2. 12 divided by 4 is 3. Multiply 3 times 4, subtract. And so the answer, or the solution to 412 divided by 4 is 103 with no remainder. I want to take a second now and just show a clip of a student demonstrating the same problem.
Okay, there are 2 ways to figure out the answer for this division problem. The first way is you can branch 412 into 412, and you divide 400 by 4, and you get 100 plus 12 divided by 4, which is 3. So 100 plus 3 is 103, and that's your answer. Another way you could show this problem is 100 times 4 equals 400. And you subtract that to find what's left over. So 2 ones subtracted by 0 equals 2, and 1/10 subtracted by 0 equals 1, and then 400 subtracted by 4 equals 0. So you can leave that. And so now you have to go to your tenth, and there's 1/10, and you can't divide 1 by 4. And so you can put a 0 there. So 0 times 4 equals 0. And 12 minus 0 is 12. So you go to your ones. So 12, 3 times 4 equals 12. And then subtract that to find what's left over. And you have nothing left over. So your answer would be 103. The next way to show this is 100 times 4 equals 400, and then you subtract that and you get 12. And so since you went by hundreds you have to go to your tens, and 1 divided by 4 you can't do, so you put a 0, and 0 times 4 equals 0, and subtract that and you get 12. And then you go to your ones, so 12 divided by 4, you get 3, and 3 times 4 equals 12, and you subtract and you get 0. So yeah.
Here's another example I'd like to use to demonstrate the way we talk through a division problem. In a traditional textbook, we teach to start in the thousands place, so 1 divided by 5. We can't divide that, so students typically will either leave it blank or put an X here. So now we need to think about the hundreds. So 18 divided by 5 would be 3. 3 times 5 is 15. We would subtract and bring down. 32 divided by 5 would be 6. 6 times 5 is 30. We subtract and bring down. 24 divided by 5 is 4. 4 times 5 is 20. We subtract and we have a remainder of 4. Now I'm going to show you a clip of a student solving the same problem going through different stages. And when you're looking at this, I want you to really think about what language we're using with kids when we're saying 18 divided by 5 is 3. No, this isn't 18 divided by 3, it's 1800 divided by 5. And that quotient is 300. And so really we're breaking this number apart into 1800, the 20, and the 4, and we subtract each time to see what remains as we go through the different place values. And I'm not convinced that in a traditional algorithm, when we teach it this way, and that's where we start, the kids are really understanding that place value. In primary mathematics, with the stages that we use, this would be the final stage. And in many textbooks, this is the initial stage. And students have a really hard time understanding this algorithm.
I'm going to show you how you divide 1,824 divided by 5 in two ways, the stacking method and the algorithm method. First, I'm going to do the stacking. So you can't divide 1,000 by 5 people, so you have to go to your hundredths, and that would be 1800s, and 1800s divided by 5 is 300s, and so 3 times 5, 300s times hundreds times 5 equals 1,500, and you subtract that to find what's left over, and that would give you 324. Since you did your hundredths, now you have to go to your tens, and that would be 32 tens. So 32 tens divided by 5 gives you 6 tens, which you could also say as 60 tens. 60. So 60 divided by 5 is 300. And so, 60 times 5 would give you 300, and then you subtract 324 by 300 to find what's left over, and you get 24. Since you have to go to your ones now, you do 24 ones, and 24 ones divided by 5 is 4. 4 times 5 gives you 20, and then 24 divided by 20 gives you 4. So you have a leftover of 4, so you have to do 364 remainder 4.
Did you say 24 divided by 20?
No, 24 minus 20. And then 364 remainder 4, or you could rename it and say 364 and 4/5.
Can you show me the algorithm?
The algorithm, now I'm going to show you the algorithm method. So you start with your thousands, and since you can't divide 1,000 by 5, you have to go to your hundreds. So 1,800 divided by 5 is 3 hundreds.
What does that 3 stand for?
300s. And so 3 times 5 is 1,500. 300s times 5 is 1,500s. So 1,824 equals 324. And so now since you used your hundreds, you got to go to your tens. And so 32 divided by 5 is 60. Or 32 tens divided by 5 is 60. And so 60 times 5 gives you 300, or 30 tens. And so 324 divided by, subtracted by 300 is 24. So since you used your tens, now you have to go to ones. So 24 ones divided by 5 gives you 4 ones. So 4 times 5 is 20, with a remainder of 4. And so 364 remainder 4, or 364 and 4/5.
One thing you noticed in the little video clips was the stages that the student took in order to get to the algorithm. looks a little different from the traditional stages we use with the subtract, multiply, bring down method of division. This is all based on foundational work done in Singapore using what's called a concrete pictorial abstract. So in 3rd grade, that student started with discs or base 10 blocks, some concrete manipulative to divide amongst 3 or 5 or whatever the divisor is. It would then lead to a pictorial model, and the pictorial would then take you to the abstract, or in this case the algorithm. But notice again that language that was being used. Another thing, you heard the student talk about 1 divided by 4, and we can't do this. The emphasis again in 3rd grade isn't on fractional pieces at this point. Of course, you could take 1,000 and divide it by 4, but at that point, the child was thinking of, if I had a $1,000 bill, I couldn't just take that 1,000, I'd have to break it into hundreds. So you saw him think of that 1,800 as 1,800, and therefore he could dispense the hundreds amongst 4 people. So this is really based on the foundations in the primary mathematics. To find out more about this and other approaches, you can go to my website, methodology.com, listed here, and find out about different institutes and different programs we have that really break down the foundations behind primary mathematics.